The sky looks still, but it isn't. Nothing in the universe ever really is. Above you, while you sleep, a quiet choreography unfolds. Not with music, but with gravity. Not with dancers, but with spheres of fire, stone, and breath. The earth spins slowly beneath your blanket. The moon traces its orbit around us, a silver sentinel. And the sun, farther away than your mind can hold, pulls us all like a patient puppeteer. You are not on a rock. You are in a rhythm. So tonight, close your eyes, and let's drift through the story of three ancient travelers: the earth, the moon, and the sun, and how their invisible connection makes every tide, every season, every moment possible. Let's begin. It begins with light, but not the kind that flickers from a lamp or spills through a window at dawn. This light is ancient, older than our world, older than our stories, older than you or me or anything we know. It comes from the sun, 93 million miles away. A sphere of hydrogen and helium burns in slow silence. Not with fire, but with fusion, where the weight of atoms is crushed until they give off light. Every second, 600 million tons of hydrogen disappear, transformed into heat and pressure and glow. That glow drifts through space, takes 8 minutes to reach your eyes, which means every time you look up at the sky, you are looking into the past. You've never seen the present sun. No one ever has. And yet, we orbit it. We depend on it. We are shaped by it. The earth is tethered to it by gravity, not tied by rope or chain, but by motion. We fall toward it, forever missing it, like a coin spinning at the edge of a bowl, trapped in an elegant curve. This is what an orbit is. Not a line, but a loop. Not a destination, but a dance. And because we move around the sun, we have days that shift, seasons that change, and shadows that stretch long in winter and vanish in summer. But you don't feel any of this. The earth moves at 67,000 miles per hour around the sun, fast enough to cross the country in 3 minutes. And yet, your glass of water doesn't ripple. Your feet stay planted. You don't hear a hum or a roar, just the quiet rustle of wind. And the sun doesn't follow us. We follow it. We orbit, not in circles, but in ellipses. Not centered, but askew. And the earth, for all its spinning, never spins straight. Its axis is tilted, 23.5 degrees off-center. A gentle lean that changes everything. Because of this lean, light lands differently depending on where we are in our path. And so, the sun paints the world in different hues. A soft spring green, a harsh summer gold, a fading autumn red, a pale winter gray. The sun does not move. We do. But from where you sit, or lie, or drift toward sleep, it feels like the sun rises and falls, like it vanishes and returns, like it's playing hide and seek behind clouds and hills. It isn't. It's always there, always burning, always glowing, always waiting. Even now, as you close your eyes, it shines somewhere. Over oceans you've never touched. Over deserts you'll never walk. Over people you'll never meet. The sun touches everything. And while you sleep, it pulls us forward, guiding our orbit, marking our days, warming our world without ever getting close. A star, a guide, a clock. And this is only the beginning of the story. Because the earth is not alone. It is watched. It is followed. It is accompanied by something smaller, colder, and just as ancient. But we'll come to that soon. Let the sun warm your thoughts for a while longer. Then we'll look toward the moon. You've probably seen it, hanging there like a coin in the sky. Not quite silver, not quite white, More like memory. The moon doesn't shine. It reflects. It takes the sun's light, light that traveled millions of miles, and tosses it gently back to Earth, like a whisper passed between old friends. But from here, it looks alive. It changes. Shrinks, grows, vanishes, returns. A shapeshifter in the sky. Some call it a crescent, a half, a full. But really, the moon is always whole. You just can't always see all of it. Because it isn't the moon that changes. It's us. It's the angle of light. It's the geometry of night. It's the way we watch. The moon orbits Earth, not in a perfect circle, but in a stretched out ellipse. It takes about 27.3 days to make a full trip. But something odd happens. From your window, the same side of the moon always faces you. Always. It spins, yes, but it spins just slowly enough to keep one face turned toward Earth at all times. This is called tidal locking. It's as if the moon is shy, forever showing you one side, forever keeping the other hidden. No one saw the far side of the moon until we sent a spacecraft. And when we did, it was quiet, rugged, unfamiliar, not dark, just different. The moon pulls at us too. Not just our eyes, but our oceans, our tides. The gravity of the moon tugs at Earth's water. Not in sudden jolts, but in long, slow waves. This is why the sea rises and falls. Not because the water moves on its own, but because the moon whispers to it. Gently, rhythmically, predictably. Every tide, every wave on the shore, is a conversation between Earth and moon. And it's not just water. The moon stabilizes Earth's tilt. Without it, our planet would wobble more wildly. Seasons would shift unpredictably, and life might never have stood a chance. You owe your spring mornings, your autumn breezes, your winter firesides, to the moon. But you never feel its pull. Only the ocean does. Only the planet beneath your feet. And in return, Earth holds the moon in place, locked in a never-ending gaze. They dance together. A cosmic duet. But this isn't the whole story. Because while the moon watches the Earth, and the Earth spins around the sun, there's something deeper going on. Something invisible, and ancient, and powerful. A force not of stone or light, but of gravity, time, and balance. Next, we'll explore how these three, the Earth, the moon, and the sun, move together. And what that motion does to time. It always does. If you could step far enough away, not just above the Earth, but beyond the pull of gravity, beyond the spinning of days and the blinking of satellites, you'd see it. The dance. Three bodies locked together. Moving. Not in chaos, but in rhythm. Earth spins on its tilted axis. The moon circles Earth. And together, they orbit the sun. But they don't travel in neat loops. There are no perfect circles. Everything sways, leans, stretches, wobbles. Earth's orbit is elliptical. A stretched oval around the sun. And as it moves, the moon follows, looping around Earth like a thread wrapping a spinning top. You wouldn't see a clean track, but a spiral, a helix. Something closer to a gentle corkscrew winding through space. And none of it stands still. The sun itself is moving, dragging the whole solar system behind it as it arcs through the galaxy. So really, Earth is spiraling around the sun, which is spiraling around the center of the Milky Way, which may be spiraling around something even larger. But we'll stay here for now, with these three, because their movements shape time, shape light, shape everything you call a day. A day isn't just 24 hours. That's only part of the story. There's the solar day, the time it takes the sun to return to the same spot in the sky. Roughly 24 hours. But the sidereal day, measured by distant stars, is actually about 23 hours and 56 minutes. The difference is caused by Earth's motion in its orbit. A tiny detail, but one that adds up. And then there's the moon. Its orbit causes our months, but not perfectly. A lunar month, called a synodic month, is about 29.5 days. That's why our calendars don't quite match the moon. Why we sometimes add days, leap years, corrections. Time doesn't tick like a clock. It breathes. It flexes. Solar eclipses, lunar eclipses, the pull of tides, the rise of seasons. They all come from this three-body ballet. They are not coincidences. They are consequences. And yet, for all this motion, you don't feel like you're moving. You sit still. Maybe on a bed, maybe on a couch, maybe with your eyes closed. And yet you are spinning, orbiting, traveling through space faster than any rocket ever built. You are a passenger on a world within a system, bound by light and gravity. And all around you, these three ancient companions keep dancing, always moving, always in step. Next, we'll look at shadows. Because when three bodies dance, sometimes they block the light, and something beautiful happens. The rhythm continues. Sometimes, when the dance lines up just right, a shadow touches the sky, and daylight bends into something ancient, something silent. It begins with a dark bite, a soft curve cutting into the sun, as if a celestial hand is slowly closing a glowing eye. This is no ordinary shadow. It belongs to the moon, and it doesn't block the sun often. Only when the tilt of the moon's orbit matches just so with the Earth's path around the sun. Only when the alignment is perfect. A solar eclipse. The moon, usually so small and far away, suddenly becomes a shield, covering the sun's face, casting its shadow onto Earth. But the shadow is not wide. It draws a path across the planet, a ribbon of darkness that races faster than sound. And if you happen to stand in just the right place, in the path of totality, you'll see day turn to night. Birds go quiet. Temperature drops. People hold their breath. And above you, the black disk of the moon hides the burning star that gives us life. And around the edges, the sun's corona spills out. A halo of fire that is always there, but never seen. Except during this. Then the moment passes. The light returns. The rhythm resumes. But it doesn't end there. The moon has its turn too. Sometimes it slides into Earth's shadow. Not disappearing, but glowing dimly red, as if blushing in the dark. A lunar eclipse. This time, everyone on the night side of Earth can see it. The sun, Earth, and moon aligned. And Earth stands in the middle, casting its shadow out into space. But Earth's shadow is curved. Always curved. A truth that ancient sailors noticed when watching the moon darken. Proof, even thousands of years ago, that the world was round. During a lunar eclipse, the moon doesn't vanish. It turns a deep copper, a rusted coin hanging in the sky. Why? Because sunlight bends. Earth's atmosphere filters and scatters it. Blues are lost. Reds remain. So the moon is painted with the color of every sunrise and every sunset on Earth, all at once. It is not a disappearance. It is a memory of light, wrapped around the world. Eclipses remind us. We are small. We are spinning. We are part of something vast. They are clocks in the sky. Predictable, ancient, beautiful. And they only happen because the sizes and distances of the sun and moon, from where we stand, are almost exactly the same in the sky. It's a coincidence so perfect, some call it cosmic design. But coincidence or not, the result is awe. And it doesn't stop there. Because the motions of these three bodies, their pushes and pulls, their spins and tilts, don't just shape shadows, they shape climate. They shape habitability. They shape life. We'll journey into the long cycles, the slow drifts of Earth's orbit and axis that quietly sculpt the history of ice and fire. The rhythm continues, and shadows always return to light. Not all motion is fast. Some of it is so slow, so gradual, that you might live your whole life and never notice it shifting beneath your feet. But Earth is not still. Even its axis, that invisible line it spins around once every 24 hours, is gently, silently wobbling, like a spinning top that doesn't quite stay upright. This wobble has a name: axial precession, a slow circle, one full sweep every 26,000 years. It changes where the North Pole points in the sky. It redraws the map of the heavens. Once, Polaris, the North Star, wasn't the North Star at all. Thousands of years from now, it won't be again. It seems small. Just a tilt. Just a direction. But over millennia, it changes everything. Now add more subtle movements. Earth's obliquity, its tilt angle, doesn't stay fixed. It shifts between about 22 and 24.5 degrees over a cycle of 41,000 years. That might not sound like much, but this small tilt controls the seasons. It decides how sunlight hits the poles, how winters stretch, how summers burn. And it's not just tilt and wobble. Earth's orbit around the sun grows more or less oval, a change called eccentricity, on a cycle of about 100,000 years. All three of these rhythms, precession, obliquity, eccentricity, combine in what scientists call Milankovitch cycles. And together, they shape the planet's climate. They bring on ice ages. They release thaws. They decide where deserts grow and where forests bloom. You see, the Earth is not just orbiting. It's swaying. It's breathing. It's dancing to a beat so slow, so deep, you'd miss it without math and stars and time. Ancient ice holds the memory. Bubbles trapped for hundreds of thousands of years whisper secrets about a world that has frozen and melted, again and again. And those rhythms continue. Right now, the Earth is tilted just over 23 degrees, precessing slowly, orbit slightly elliptical. The next ice age will come. But not yet. For now, we ride the crest of a warm interglacial period, a brief pause between frozen pulses. And through it all, the sun shines, the moon pulls, and Earth leans and spins in its ancient rhythm. It's strange, isn't it? That climate, so often thought of as wind and rain and clouds, is shaped, in part, by geometry, by the angle of a tilt, by the stretch of a path, by the slow swirl of a planetary axis that you will never see turn. But it turns, always, quietly, forever. We'll now look at the moon, not just as a rock in the sky, but as a sculptor of tides, a guardian of balance, and a possible reason Earth is even habitable at all. It's always there, hovering silently over the horizon, sometimes round and golden, sometimes pale and sliced like a fingernail, sometimes hidden entirely. The moon. You know it as a companion, a constant presence in the night sky. But the moon is more than a light in the darkness. It is a protector, a sculptor, a quiet force keeping Earth in balance. Without it, life, as we know it, might never have happened at all. Let's start with something gentle. Tides. They rise and fall, twice a day, as if Earth itself were breathing with the ocean. That rhythm comes from the moon. Its gravity tugs at the water, pulling it forward as Earth spins beneath it. The result? A wave of force rolling around the globe, raising seas, moving coastlines, feeding estuaries. Tides shape the living world. They create tidal pools where strange creatures evolve. They stir nutrients through vast waters. They may have helped coax life from the sea to the land. But it's not just water the moon moves. It moves Earth's spin. The moon slows our rotation. Imperceptibly, but inevitably. Long ago, a day was just 6 hours long. Today, it's 24. And it's still changing. The moon, by pulling at the Earth, steals a little of our momentum. A quiet break on a spinning world. And without it, that spin could wobble. Earth's axis, already tilted, might lurch wildly, tipping from side to side over time. That would be catastrophic for climate, for seasons, for life. But the moon, like a hand on a spinning top, keeps the axis mostly stable. Just enough tilt for seasons, not enough for chaos. And then there's the origin story, the great mystery. How did the moon get here? The leading theory says it came from violence. A Mars-sized body colliding with Earth in the early days of the solar system. Debris from the impact spiraled into orbit and coalesced into the moon. From destruction, a companion. And perhaps, from that companion, the calm conditions needed for oceans, for weather, for breath. Tonight, as you fall asleep, know that the moon is pulling. On the tides, on the Earth, on you. 250,000 miles away, but deeply, intimately involved in every moment. The moon keeps the rhythm steady, keeps the climate gentle, keeps the chaos at bay. In the next part, we'll trace the sun's role, not just as a source of light, but as the engine behind nearly everything that moves or grows on Earth. Always orbiting, always watching, always pulling. It doesn't rise. Not really. It doesn't set either. We're the ones turning, rotating into the daylight. But it feels like a rising. It feels like the start of something. The sun. Not just a light. Not just a heat. But a 4.6 billion-year-old furnace. Floating in space, powering the very possibility of life. Without it, nothing breathes. Nothing grows. Nothing moves. The sun accounts for 99.8% of all the mass in the solar system. It's so large. You could fit more than 1 million Earths inside it. But despite its size, it's powered by something delicate: fusion. At its core, hydrogen atoms are crushed together until they become helium, releasing energy with every transformation. Every sunrise is that energy. Trillions of nuclear reactions per second, radiating across 93 million miles of space, finally brushing your skin. It's warmth you didn't ask for, light you didn't earn, but without it, you would never have been born. Everything green on Earth owes its color, its energy, to the sun. Photosynthesis is a translation. Light into sugar, sunlight into food, into forests, grains, algae, flowers, into breath. The oxygen you're breathing now was born from the sunlight, trapped in ancient leaves. Even the food you eat carries sunlight inside it. Sunlight stored in starch. Sunlight buried in meat. Sunlight that traveled across space to become part of your body. But the sun isn't just life. It's also time. Your circadian rhythm, the body's sense of day and night, is guided by sunlight. The sun tells your body when to sleep, when to wake, when to heal. Without it, your inner clock would drift. The sun is the heartbeat of everything earthly. It marks the seasons, triggers migrations, wakens flowers, guides birds. And while it feels gentle, it is also dangerous. Solar flares can eject massive bursts of radiation. The sun breathes fire, and Earth's magnetic field must shield us from it. More on that soon. The sun is not static. It rotates. It ages. It changes. One day, it will die. It will expand into a red giant, consume Mercury and Venus, maybe Earth, an afterthought, collapse into a white dwarf, a hot cinder of a once living star. But not for billions of years. Tonight, it's still burning, still shining, still feeding every leaf, every breath, every thought. And we orbit it, carried by gravity, bathed in golden fire. We'll explore the invisible dance. How the pull between Earth and Sun keeps us in motion and holds everything together. There's no tether. No rope holding us in place. No sound. No wind. No friction. Just space. Just motion. And a force so constant, we forget it's there. Gravity. It doesn't push. It doesn't pull like you'd expect. It curves space. And in that curve, we fall forever around the sun. Earth doesn't travel in a perfect circle. It follows an ellipse, tilted ever so slightly. Close in January. Farther in July. But that slight wobble, that quiet dance, creates seasons. Not because of distance, but because of tilt. The Earth leans. About 23.5 degrees. Not much, but just enough to shift the sun's gaze, northward and southward across the year. That lean gives us summer and winter, equator and pole, growth and dormancy. It's a tilt held in place, in part, by the moon, and its a motion sustained by the sun's gravity. A loop, a balance, a conversation between two bodies in an ocean of silence. Imagine Earth without that gravity. Drift too close. We're scorched. Too far. Frozen. But we don't crash into the sun, and we don't fly away. We fall sideways, constantly. That's what an orbit is. We are always falling, but we never land. Gravity is not only glue. It's a metronome. The sun's gravity keeps the planets in line, keeps the solar system coherent. Mars doesn't wander. Jupiter doesn't collide. Saturn loops faithfully in its lane. And we, tiny, fragile, are cradled in a gravity well that's been stable for billions of years. Stable enough for oceans to form, for cells to divide, for species to evolve, for stories to be told. And there's more. Gravity shapes time. Near massive objects, time runs slower. You age differently in orbit than on the ground. Your clock ticks faster, the higher you go. Astronauts come home millions of nanoseconds younger than they would have been on Earth. Gravity isn't just a force. It's the architecture of reality. So tonight, as you lie still, your body pressed gently to the earth, know that this stillness is part of a much larger motion. You're spinning. You're orbiting. You're part of a perfect fall. And tomorrow, the sun will rise, not because it moved, but because you did. We'll turn back to the moon and explore its strange and silent surface, and how it echoes our story more than you might expect. The moon doesn't shine. It reflects. A borrowed glow, scattered light, a ghost of the sun's fire caught on powdered stone. And yet, when you look up, it feels alive. It feels like something is watching. Because in a way, it is. It always shows us the same face. Not because it's frozen, but because it rotates just once, for every orbit around the Earth. This is tidal locking. A cosmic coincidence, or a quiet choreography perfected over eons. We see one face. Always. A pale, cratered gaze that has never looked away. The far side, the so-called dark side, remains turned from us. Not darker, just hidden, unseen by human eyes until 1959. But the moon has always seen us. It pulls at our oceans. That's not poetry. It's physics. The moon's gravity stretches the seas. It draws the water forward, creating bulges, tides that move in rhythm. With a satellite 238,855 miles away, it's not just the oceans. It pulls at the crust, at you. Your body feels the tide. You're mostly water, after all. And though the pull is slight, it's there. The moon is whispering, tugging, turning your planet ever so gently. It didn't start that way. The moon was likely born from violence. A planetary collision, an object the size of Mars, slammed into the early Earth. Debris scattered. Molten rock danced in orbit, and over time, it coalesced, rounded itself out, into the moon. A piece of Earth, ripped away, now circling forever. It stabilized our tilt. It slowed our spin. It made long-term climate stability possible. And without it, life as we know it may never have formed. But it is not lifeless. Not entirely. The surface is still. Yes, but it's marked by memory. Craters that record every impact. Dust that's never been washed by rain. Footprints that will outlast empires. The moon doesn't change quickly, but it changes us. There are myths carved into it. Wolves howl to it. Lovers swear by it. Calendars follow its pulse. It marks time for those without clocks. It governs tides, menstrual cycles, harvests. Even now, we look to it and wonder. What secrets are still hidden on that silent stone? We'll descend into the heart of shadow, to where eclipses blur the line between coincidence and design. There is a moment when everything lines up. Sun, moon, earth. 3 celestial bodies, locked in motion, briefly fall into perfect alignment. And the result is shadow. A solar eclipse. The moon, though tiny, drifts just the right distance between us and the sun, blocking its light, casting a long, slender shadow onto Earth's surface. It doesn't last long. A few minutes. Maybe 7, if you're lucky. But for those few minutes, day becomes night. Birds go silent. Stars peek through the sky. And a black disk hangs where the sun once burned. It feels supernatural. Ancient. Like the sky is breathing. The moon is 400 times smaller than the sun. But it's also about 400 times closer to Earth. A cosmic coincidence. Or just geometry in motion. Because of this ratio, the moon fits perfectly over the sun's face. No more. No less. Not forever. The moon is drifting away. About 3.8 centimeters per year. In 600 million years, total eclipses will be gone. Right now, we live in the blink of an eye where they're possible. Lunar eclipses happen when the order flips. The Earth stands between sun and moon. Its shadow falls across the moon's surface, and it turns red. Not because the moon burns, but because our atmosphere bends sunlight, letting only the long red wavelengths slip past. So the moon glows like an ember in Earth's curved shadow. A blood moon. An omen to some. A marvel to others. But at its core, just light and shadow and angles. Eclipses have shaped myths. Kings have trembled. Animals have fled. In ancient China, people would bang pots to scare off the celestial dragon, eating the sun. In Mesoamerica, eclipses foretold fate. Wars, deaths, changes. Even now, we gather with glasses and cameras, waiting for a fleeting glimpse of cosmic precision. But an eclipse isn't just a shadow. It's a map. A moment when the geometry of the cosmos becomes visible. It's proof that we live on a sphere, orbiting another, shadowed by another still. Its gravity made visible. Its motion paused. We'll trace how all of this has been written into time, into calendars, rituals, and civilizations. Long before clocks, before wristwatches ticked or satellites pulsed time from space, we had the sky. The sun rose and fell. The moon waxed and waned. And humanity counted. We carved time into stone, not with numbers, but with shadows. Stonehenge, Chichen Itza, Nabta Playa, ancient calendars designed not to predict stock markets or appointments, but the return of light. When to plant, when to harvest, when the rains would come, when to fast, when to mourn, and always when the sun would stand still, the solstice, or cross the sky's middle line, the equinox. Time etched into architecture. The moon offered its own rhythm, a soft pulse, roughly 29.5 days from full to full. Some called it a month. Others followed its phases with ceremony. Crescent to half, half to whole, whole to gone. A lunar calendar. But here's the twist. The moon's cycle doesn't fit neatly into Earth's solar year. 12 moons leave you short by about 11 days. So cultures adapted. Some added leap months. Others tied lunar cycles to solar ones, creating lunisolar calendars. Even now, festivals like Ramadan, Passover, and the Chinese New Year dance to the beat of both the sun and the moon. The Earth's tilt, its 23.5-degree lean, is the metronome of seasons. It decides the length of shadows, the warmth of winds, the bloom and decay of life itself. And it's stabilized not by luck, but by the moon. Without the moon's tug, Earth would wobble wildly, spinning like a lopsided top. Seasons would shift unpredictably. Climate would careen. Instead, we sway gently. Winter follows fall. Spring follows frost. Year after year. This celestial rhythm, sun, earth, moon. It's not just science. It's ritual. It's memory. It's the reason we celebrate birthdays, count anniversaries, honor solstices. Every culture has looked up and made meaning from the sky's slow turning. Time became story. Story became belief. Belief became civilization. And still, we turn. We'll descend deeper into this gravity-bonded trio to witness how invisible forces, like magnetism and tides, tie the fate of these three bodies together in ways we're only beginning to understand. Twice a day, the ocean inhales. Twice a day, it exhales. Waves rise, reach, and fall back. Not because of storms or winds, but because of a distant partner pulling gently from above. The moon. It doesn't just light our night sky, it moves the ocean. Its gravity tugs at Earth's waters, lifting them ever so slightly into a bulge. That bulge becomes a high tide. But here's the strange part. There's a second bulge on the other side of the planet. An equal pull in the opposite direction. Why? Because while the moon pulls Earth's oceans toward it, it also pulls Earth's body slightly off-center. And the water behind, left trailing, bulges outward in return. Two tides, always chasing the moon's path. But the sun plays its part too. Its gravity pulls on Earth, less than the moon's, but powerful nonetheless. When the sun and moon align, at new moon and full moon, their poles combine. Tides grow taller. Spring tides, named not for the season, but for their leap in size. When the sun and moon form a right angle, at quarter moons, their poles cancel. Tides shrink. Neap tides. Quiet, withdrawn. It's a celestial breathing pattern. In, out, strong, soft. Tides aren't just waves. They shape entire coastlines. They carve cliffs, nurture estuaries, fuel ecosystems. And for creatures who live where land meets sea, tides are the clock by which life runs. Crabs wait for low tide. Barnacles close for high. Corals spawn in synchrony with the lunar cycle. Even some humans, fishermen, sailors, monks, have tuned their lives to the slow heartbeat of the tides. And tides do more than move water. They move energy. The friction of water tugged across the seabed slows Earth's rotation just a little bit, about 1.7 milliseconds per century. The moon, in turn, drifts farther away. A slow, quiet farewell at 3.8 centimeters a year. A dance where one partner spins and the other steps back. The moon pulls. The earth follows. And somewhere, you drift between them. Beneath your feet, deeper than any cave, past stone and fire, there is motion. Not silence. Not stillness. But churning. Liquid metal. Molten iron. Spinning. This is Earth's core. And it does something no other part of our planet can do. It creates an invisible shield. The magnetic field. You can't see it. You can't touch it. But without it, you wouldn't be here. It stretches outward, a cocoon of energy, reaching thousands of miles into space. A silent guardian against a deadly storm. Because space is not empty. The sun, as bright and life-giving as it is, throws tantrums. It hurls solar wind, streams of charged particles that scream through the void at millions of miles per hour. To us, they're invisible. But to Earth, they're deadly. These particles could strip away our atmosphere, shred satellites, fry electronics, and bathe the planet in radiation. But they don't. Because of that molten core, still turning, still spinning, the magnetic field bends the solar wind. It pushes it aside, like water splitting around a rock, like a cloak wrapping around the world. And where the field lines trap some of those particles, they spiral toward the poles, colliding with the atmosphere. There, they paint the sky. The auroras, northern lights, southern lights, rippling curtains of green, purple, red. They shimmer. They dance. They are the only visible trace of this invisible battle, happening every moment. But this shield isn't static. It shifts. It wobbles. It even flips. Once every few 100,000 years, the magnetic poles reverse. North becomes south. Compasses spin. And during the transition, the shield weakens. We don't know what that means for us. But it reminds us, this shield, like everything else, is alive, moving, changing. Take a compass. Hold it still. Watch the needle point north. But why? There's no glowing arrow in the sky. No signpost nailed to the heavens. And yet, it always knows. The magnetic field of Earth isn't just a shield. It's a map. Stretching from the molten core to the edge of space, it wraps the planet in invisible lines. They emerge from the south, curve out into space, and dive back in at the north. They guide birds. They guide bees. They guide whales swimming through black ocean miles. And once, they guided sailors across a featureless sea, long before GPS. But they are not stable. Not truly. These magnetic lines shimmer. They twist. They fluctuate with solar storms, with movements in the core, with the subtle ballet of cosmic interference. Even the moon pulls on Earth's magnetic field. Gently, but enough to cause it to dance, to shift, to whisper new directions. And the sun can shout. During solar flares and coronal mass ejections, bursts of solar plasma reach Earth. And when they crash into the magnetosphere, they don't knock politely. They rattle the field. They shake its lines. They ripple through space like a bell that's been struck. These are magnetic storms. They can disable satellites, confuse animals, interrupt power grids, even change the color of the aurora, more red, more violent. And they remind us, we live in a system far from still. Even Earth's own magnetic poles are slowly, steadily wandering. The North Pole is racing, away from Canada toward Siberia. Why? We're still not sure. And one day, maybe soon, maybe in 1,000 years, the field might flip. Your compass needle would point south. Whales might lose their path. Satellites might glitch and fall. The aurora might paint the skies of Rome. But don't worry. This has happened before. Many times. The Earth has flipped its magnetic field 180 degrees, at least several hundred times. And life kept going. There it is, hanging in the night sky, cold, cratered, and unblinking. The moon. It doesn't twinkle like stars. It doesn't blaze like the sun. It just is. But for all its quiet, the moon is a master of influence. It pulls on the oceans, stretching them into bulges, tides. It pulls on the Earth itself, just enough to rock the planet, a subtle wobble, called lunar libration. It even helps steady the Earth's axis, like a parent's hand on a spinning top. Without it, Earth's tilt could drift wildly, swinging from upright to sideways. And if the tilt changed, so would everything else. The seasons, the climate, even evolution. The moon is our cosmic anchor. But it wasn't always there. Once, billions of years ago, a Mars-sized object slammed into Earth. The collision was cataclysmic. Debris flew into space, and slowly, it formed the moon. Our moon, born of violence. Now a symbol of calm. But it's not still. Each year, the moon drifts away, about 3.8 centimeters. Slow, unnoticeable, but steady. And one day, long after your name is dust, long after cities crumble, the moon may be too far to hold Earth steady. The tides may weaken. The wobble may return. The balance we know could slowly unravel. Yet for now, it hangs there, faithful, predictable, shining with borrowed light, casting its rhythm onto waves, onto sleep cycles, onto stories passed down since fire met night. It is Earth's companion, its mirror, its tide bringer, its ancient witness. Every morning, you wake up to a miracle that feels ordinary. A slow spill of gold over rooftops, light pushing back night. You call it a sunrise. But the sun never moved. You did. The Earth spins, like a tilted top, making one full rotation every 24 hours. You stand on its skin, and as it turns, you fall into the light, then fall out again. The sunrise is your motion, not the sun's. The sun is still, steady, unfathomably massive. It is a nuclear furnace, burning 600 million tons of hydrogen every second. Each second, 600 million tons. And from that destruction comes light, warmth, life. The energy that touches your skin today was born in the sun's core 100,000 years ago. It fought its way out, bounced between particles, then finally broke free, streaming 93 million miles to reach you. It arrives, and you call it morning. You owe everything to that light. Your food. Plants turn sunlight into sugar. your bones, built by calcium delivered by dying stars, but held in place thanks to vitamin D, activated by the sun. Your mood, your rhythm, your very sleep-wake cycle, all entrained by the sun's dance with the earth. But the sun is not just a giver. It is also a taker. It pulls Earth, holds us in orbit, at just the right distance. Not too close, not too far. If the sun were any smaller, we'd freeze. Any bigger, we'd burn. Its size is perfect, but only for a time. One day, billions of years from now, the sun will grow. It will swell into a red giant, engulfing Mercury, then Venus, and maybe Earth. It will shed its layers, leave behind a white dwarf, a stellar ghost, fading in silence. But you don't have to worry about that. Tonight, the sun is still burning, still holding Earth, still guiding its little moons and its fragile blue marble through space. Before clocks, before calendars, before counting itself, humans looked up. They didn't need to invent time. They just watched it. The rhythm of light and dark, the steady return of shadows, the tilt of constellations, the growing, glowing curve of the moon. Time was never just numbers. It was nature. Our days come from Earth's spin. One full turn, a day. Our months, the moon's journey around us. A slow loop, from new to full to new again. And the year? A single path around the sun. 365 days, 5 hours, 48 minutes, and 45 seconds. Not even time is exact. It drifts, like the sky. And so we adjust. Every 4 years, a leap day. A little pause in February to stitch time back in place. But even that is just an approximation. A truce with the heavens. Seasons are born from Earth's tilt. 23.5 degrees, just enough to lean. When we tilt toward the sun, we call it summer. When we tilt away, we call it winter. And everything in between is the journey. Without the tilt, there would be no seasons. No autumn leaves. No spring thaw. No reason to mark one part of the year as special from another. Just sameness. Endless, sunlit sameness. So we made stories. Named full moons. Planted crops to the rhythm of lunar light. We learned that eclipses, those eerie silences in the sky, could be predicted by counting the steps of this cosmic waltz. The Earth, the moon, and the sun don't just move. They teach. They taught us when to sow, when to reap, when to rest. And even now, with digital clocks glowing on your nightstand, your body still remembers. It drifts into sleep when darkness falls. It stirs when light returns. Inside you, circadian rhythms pulse, tiny echoes of a much larger pattern that started with the sky. It starts with a silence. Bird song stops. The wind stills. And in the middle of the day, the world dims. Not gradually, like dusk, but suddenly, like someone flipped a cosmic switch. You look up, and the sun is missing. An eclipse. Not a trick. Not a myth. But a perfect alignment. So perfect, it feels impossible. The moon, tiny compared to the sun, is 400 times smaller. And yet, it's also 400 times closer. Just enough to match the sun's size in the sky with eerie precision. That's why eclipses work. Because of coincidence. Because of math. Because of wonder. The moon passes in front of the sun. For a few minutes, it fits exactly. Like a lock. Like a riddle solved by gravity. And all around you, shadows ripple. Animals panic. People weep. Because no matter how much we understand, it still feels like magic. Solar eclipses, lunar eclipses, they're all choreography. The Earth casts its shadow on the moon. The moon casts its shadow on the Earth. One blocks light, the other blocks certainty. Eclipses remind us that our sky is not fixed. It's alive. Ancient civilizations feared them, thought the sun was being eaten, swallowed by dragons or gods or spirits. But now, we know better. And somehow, that makes it even more beautiful. Because now, we can predict it to the second. We can point and say, there, on that day, at that hour, look up. And when it happens, we still hold our breath. But eclipses don't just entertain. They reveal. In the darkened halo of a solar eclipse, we saw the sun's corona, its outer atmosphere, millions of degrees hotter than its surface. In that moment of darkness, we discovered heat we didn't know existed. Sometimes, you have to block the light to see more clearly. Twice a day, the ocean breathes. Not with lungs, but with gravity. Not with sound, but with rhythm. The tide rolls in, and the tide rolls out, and most people never ask why. The answer: the moon. Its gravity tugs at Earth. Not enough to lift you off the ground, but enough to lift the sea. Water bulges toward the moon, a liquid bow, drawn by an invisible string. But here's the strange part. There's a second bulge on the opposite side of Earth. Why? Because Earth itself is being pulled slightly, leaving the far side's water behind. One pull. Two humps. High tide comes where the moon is. High tide comes again, 12 hours later, on the opposite side. But the sun plays a part too. Its gravity joins the dance. Sometimes it lines up with the moon, pulling in the same direction. And the tides grow stronger. Spring tides. Sometimes the sun and moon pull at angles, fighting each other. And the tides shrink. Neap tides. Even the word neap sounds like a whispered lull. The result? An ocean that's never still. A shoreline that breathes. A rhythm older than timekeeping itself. And you're full of water too. 70% of your body moved in tiny ways by the same pull. In the silence of night, some people say they feel it. That tug in their bones. That hum beneath their skin. The moon doesn't just light the sky. It touches you. Long before humans kept time, the sea did. No clocks. No calendars. Just the breath of the ocean. In and out. In and out. And life listened. On distant shores, tiny creatures began to move with the rhythm of the tide. Crabs that scuttle only when the moon is full. Worms that rise from the sand to spawn on the precise night when tides swell highest. They don't own watches. They don't check the forecast. But they know. Their bodies remember what the sea tells them. Even corals, rooted and silent, time their great spawning rituals to the moon. Billions of eggs released on one single moonlit night. A slow, glowing snow beneath the waves. Because the moon doesn't just pull water. It pulls biology. It pulls memory. And eventually, it pulled us. The first creatures crawled from the sea in rhythm with the tides. Land became possible because water made its retreat predictable. And when humans appeared, we kept that rhythm. Fishermen timed their nets. Sailors mapped the tides. Ancient temples aligned with moonrise. Calendars were born not from the stars, but from the patterns of light and pull. Even now, the moon affects our sleep, our hormones, perhaps even our dreams. We evolved with a sky that moves, and inside us, some part still moves with it. So if you ever feel strange, on a full moon night, restless, wakeful, like the world is louder than usual. You're not imagining it. You're just remembering that you are water, shaped by gravity, taught by the tide. It feels permanent. That pale circle in the sky. It rises, it sets. Night after night, like a loyal companion walking quietly beside Earth. But what if it didn't? What if the moon drifted away? It's not impossible. In fact, it already is. Each year, the moon moves a tiny bit farther, about 3.8 centimeters, away from us. At this rate, billions of years from now, it will have drifted too far to lock into our tides. The partnership will end. But what if it happened tomorrow? The nights would darken. A haunting emptiness would fill the sky. No more silver glow. No more familiar faces. But that would only be the beginning. Without the moon's gravitational pull, the tides would shrink to barely a whisper. No more crashing surf. No more regular rise and fall. The sea would become unpredictable. Quiet in the wrong ways, angry in others. Coastal ecosystems, the delicate places where ocean kisses land, would begin to collapse. Creatures that spawn with the tide would lose their clock. Species would vanish. And the earth itself would wobble. The moon acts like a cosmic stabilizer, keeping our planet's axis tilted just so, 23.5 degrees. Without it, Earth would tilt wildly over time. The seasons would become erratic. The tropics might freeze. The poles might burn. And time would lose its rhythm. No more lunar calendars. No more crescent moons to mark beginnings. No more pull on our ancient biology. Sleep cycles would shift. Migration patterns would fail. Even human cultures, those who still look to the moon for ritual, would feel its absence in the soul. We take it for granted, that glowing rock above us. But if it left, we would feel it everywhere. Not as a sound, but as silence. And the strangest part, it's still leaving. Very slowly, like a friend, walking backward into the dark. Every morning, we say the sun has risen. But it hasn't. The sun didn't move. We did. Our little planet spun toward the light, like a dancer turning back to the spotlight. It's easy to forget, because from here, it feels like we're still, solid, stable, like the ground beneath our feet will never shift. But Earth is always spinning, 1,000 miles an hour at the equator. Right now, you're moving, even if you feel like you aren't. The stars blur, the clouds drift, but only because we are rotating through them. Day and night aren't opposites. They're just shadows and angles. The sun stays in place, a fiery anchor in the black sea of space. We orbit it, but we also spin on our own axis, chasing its light, leaving its warmth, and then returning to it again, over and over, like breathing. And because we spin, we know time. Sunrises mark beginnings. Sunsets mark rest. But neither are the sun's doing. They are ours. We built hours and minutes on the back of a turning planet. A cosmic rotation, translated into calendars, clocks, deadlines. And as Earth spins, the moon tugs at it. The sun pulls at it. Together, they shape more than just days. They shape everything. Seasons, weather, currents, the slow rhythm of life on this rock. Time is not just seconds ticking. It's sunlight moving across your skin. It's the turn of the earth beneath your feet. You've never touched the sun, but it's touched you. It touches you now, not with flame or fire, but with particles, winds, whispers. The sun is breathing, not like we do, but in great invisible gusts of charged particles, a solar wind, blowing across the solar system at over 1 million miles per hour. These winds leave the sun's corona, its hot outer layer, and stream out in all directions. They travel far beyond Earth, even past Pluto, pushing the edge of the solar system outward like lungs expanding. When those particles reach Earth, they meet resistance. Our magnetic field, our invisible shield. It bends them, slows them, redirects them, like water hitting a stone. But sometimes, a few particles slip through, especially near the poles. They collide with atoms in our atmosphere, exciting them, and then they glow. The northern lights, the aurora, the sky, blushing from the sun's breath. You can't see the solar wind, but it's always there, shaping satellites, distorting radio signals, even affecting birds as they migrate using Earth's magnetic map. You are surrounded by the sun's breath, not scorched, but cradled, protected, but changed. Even your bones owe something to it. Sunlight triggers vitamin D production. That invisible radiation reaches through skin and teaches cells to strengthen your skeleton. You literally carry the sun in your marrow. It's quiet. Too quiet for what's really happening. Every second, the moon tugs at Earth. Not in anger. Not in violence. Just persistence. The oceans rise toward her, then fall away. She pulls at the water, but she also pulls at time. You see, as the moon drags our tides, she also drags our rotation. Earth spins slower than it used to. A day, once 22 hours long, is now 24. Millions of years from now, a day will stretch even further. And the moon? She's slowly backing away, inch by inch. A relationship stretching thin, but never breaking. So, if you feel like time is slipping, maybe it is. The moon is taking it, and leaving behind a quieter Earth. There's something strange about being Earth. We are held in place by two opposing forces, the burning grip of the sun and the silver pull of the moon. The sun feeds us, warms us, keeps us spinning around it like a faithful child. The moon shapes us, slows us, bends our oceans and softens our nights. And in between, Earth wobbles, not perfectly, not always gracefully. Our tilt, our seasons, our storms, they're all part of this balancing act. Sometimes, we even cast shadows on each other. The Earth eclipses the moon. The moon blocks the sun. Light and dark, interrupted by geometry. We are not alone. We are always reacting, responding, rippling. Earth is not just a planet. It's a shadow, caught between two fires. You are not separate from this story. Your heartbeat has the rhythm of the tides. Your bones formed in sunlight. Your sleep, your days, your dreams, all scripted by this cosmic choreography. The sun gave you time. The moon gave you motion. Earth gave you breath. And together, they gave you life. This isn't mythology. It's science. But it's also poetry. The kind written in light and shadow, in orbit and pull, in seconds and centuries. Tonight, when you close your eyes, you'll spin silently with Earth, under a moonlit sky, within the gravity of a distant sun, carried by a cosmic waltz, older than thought itself.